didn't think it would be this difficult to. There we go. All right, so I am doing a talk on how to do SQL cheaply. And the reason for that is that was the argument I convinced Sonic Drive-In to, am I loud enough? Am I close enough to this? So that's going to look really good on Twitch, isn't it? Yeah, sometimes you forget you're being filmed. We had this data coming in. It was an IoT type of thing, and there's a huge amount of data, and we deployed the POP system. Have you been to a Sonic and you have a little, that's an IoT device, and it generates actually quite a lot of data, which has very little value, but we store it. So they were like, all right, we're going to put this to Microsoft SQL. And the DBAs were like, all right, we'll need $8 million for the first 3 years. And I said, I can do it cheaper. So about 10 cents on the dollar now we store it, right? And just honestly, why would you want to spend all that money storing it in really high-speed drives when nobody's querying it that much? Nobody's updating it that much. It just comes in, and every once in a while someone goes, hey, let's go look at that POP state and see if it says that. And 4 weeks later they go, I'm tired of you looking at it. Did you find anything? I said, no. So that's how it works. But I can do it cheaply. So we're going to talk about how that works. Has anyone done Hive? Okay. All right. Can you leave? No. I don't want anyone to contradict me. So, no, I'm teasing. Presto? Okay. Yeah, same thing. Spark. Yeah? Wait a minute. I didn't recognize you with the tie. Did you find somebody for big data? Okay. All right. We'll talk later. All right. So so that's what we're going to talk about. Mostly because we use AWS, and that's kind of what comes in EMR. Any other ones you guys know about? Something similar to that? No? All right. So what is Hive? Hive is an open source software product. It's free, right? And basically what it does is it reads and manages large data sets sitting in a distributed storage system, executes queries in a distributed processing system using SQL syntax, right? So what does that mean? It means that I don't put the data inside of Hive. I give Hive a description of what the data looks like on the drive, right? So I say, hey, this data is structured this way. I don't put it in structured, right? I expect it to be semi-structured, but I'm not saying, hey, this data is structured this way. It's sitting here in this drive, right? So I don't ever spend any money storing it in a system that's dedicated to one thing, right? I put it in very cheap storage, using commodity hardware, using cheap drives, and one of the ways I make it fast, right, is I distribute the work across many machines, right? So while Microsoft SQL has this really big machine, right, I've got hundreds or thousands of small machines, right? And I distribute the work across it, and I do it quickly in parallel, right? So that turns your 12-hour query into an hour and a half, right? It also turns your sub-second query into a minute and a half, right? So it's not an OLTP. Also, it says writing, and they're lying. It does not write. It's horrible. So there's ways to get the data. Just put it straight into the drive. Don't use Hive. All right. So how does Hive work? Right? So basically through a command line, JDBC, ODBC, business intelligence tool sitting in front of JDBC or ODBC, you begin interacting with Hive. Right? Hive has this thing called a planner and an execution engine. And it goes down and it says down to that relational database down there in that meta store, it says, hey, what does the data look like? And it takes that data and says, okay, I have these 3 tables, I want to interact with them, I want to join, I'm going to pull these columns out. I'm going to build a directed acyclic graph, a DAG, right, of execution to achieve the end goal, right? And then it says, hey, Apache Tez, MapReduce, Apache Spark, go execute it. Goes and reads the data off the hard drive, off of HDFS, off of S3, off of whatever distributed file system you have, runs off of Hive, that kind of thing. I'm sorry, not Hive, HBase or whatever, right? And executes the graph. And each one of these executors, right, have some advantages, all right? So Hive is mostly an ETL tool these days. It's slow, it takes a while to execute, but at the end of the day, it gets there, all right? So especially if you use MapReduce, it's going to be slow, but it can do almost anything, right? It can do almost all the data you have, especially, even if you don't have a lot of machines. It will work through the graph. One of the things that makes this cheap, right, is I don't have this hardware dedicated to SQL, dedicated to this one purpose. I have this distributed set of hardware that is managed by a thing called Yarn, or Mesos, or Kubernetes, but mostly Yarn, right? And Yarn says, hey, job, you want to do this? Let me get you some of the resources and give it to you, right? So if it's Hive, it'll go get resources and give it to Hive. If it's Spark, if it's some other job, if it's Pig, if it's whatever you write, right, or whatever tool you're using, uses resources on the machine. So the machine isn't, hey, give me that $500,000 machine and I'll dedicate it to Microsoft SQL. Hey, give me $200,000 worth of hardware and I'll use it for anything you want. Because I have this thing called Yarn, right? It's called a yet another resource negotiator. And I say, Yarn, give me some CPU, give me some memory, right? Okay, so a mechanism to impose structure, we talked about that. So I'm not putting it into the system. The system's not managing it, and I put it in a hard drive and I manage it there. I just make sure that the metadata is there. That makes my life a lot cheaper. It's a lot cheaper to store stuff in an object store, distributed object store. You can almost get it anywhere, right? Store it where you want. Has multiple execution managers. Uses SQL. And you can get some sub-second query responses. What I'll show you doesn't look like it. I don't know how they say that, but there is a possibility. It's extensible, right? One of the things I really love about Spark is I can write something in SQL, use the results of that, and modify it with Scala or Python, do stuff with it there, and then execute more SQL against it. Because sometimes things in SQL make things wonderful. Sometimes they make them a pain in the rear, right? So it's so easier to do it in code. Now you can do this with Hive by putting the code in a UDF. Okay. Now, Hive uses multiple formats. Probably the 2 most popular formats are Parquet and Orc. All right? The advantage to that is because Hive is a more warehousing tool, right? It's not an OLT tool. It stores it in columnar format. Do you guys understand the value of columnar format? Yeah. Yeah. All right, so you have, if you read by row, right, and you only need 4 columns, and you have a 400-column row, you have to read 380 extra columns to get all your data, right? With columnar format, and what happens in an analytical system is you're generally doing a large set of data. You're processing several years worth of data. It goes in and says, hey, I want to read these 4 columns. And because the data is stored in columnar format, compressed, and also replicated, so if I have, so Sonic has 3,500 stores, right? I have 400 million rows in ticket data, right? So do I repeat that store ID 4 million times? Now I repeat it about 3,500 times. And I just reference it, right? So it also reduces how much you have to read, right? So you say, hey, get these 6 columns, do this to it. I only need to read those 6 columns. And that is a huge speed improvement, right? Instead of reading by the row, I'm reading by the column. Does that make sense? Yeah. It's also really, that's one of the reasons you'll see in big data, you'll see these long rows, right? Because what I like to do, right, is I have ticket header, I have the store dimension, and I have the time dimension. And I love to drop that in as a single row, right? Because now no one has to connect it and worry about how it's connected. And with ticket detail, I check in the product table dimension, and then often the time dimension. That's just, and that happens every time someone does an analysis with that data. So I preset it with this, and it's no big deal, right? I can store a ticket header in 4 or 5 different formats based on how it's analyzed, right? Hooked up to different dimensions, because it's cheap. It doesn't cost anything. It's almost nothing. All I got to do is say, Hive, this is how you query it. And there's no hardware or software being used until I query it, right? So it kind of changes the way you look at it. Not OLPT. Hive, again, like I'm saying, is the slowest of the 3. But it's the most reliable. Okay, Presto. Presto, anyone know who Presto is? Presto is written by Facebook. And Presto is the primary analytical engine Facebook uses. They do millions and millions of queries against petabytes and petabytes of data. It does something very similar, right? It actually uses a Hive metastore and other types of metastores, but primarily the Hive metastore, to describe what the data looks like on disk, right? But it has an improved engine that's more dedicated to ad hoc querying. So if you have a team that does a lot of ad hoc querying, we have a performance analysis team, that's the tool, right? This is the tool you want to use if you want to do it cheaply. It'll say, right, that and we did this, like we had some S3 data and we had some data in Redshift, and we were able to process it, right? But what happens is the minute you begin joining sources across that boundary, Presto needs to pull in the data, right? And pull in the data, and then do it in memory. And that begins to become really time consuming. So you have to be careful if you're using different data sources and you're combining them, but you can call different data from different data sources and execute them in the same query and treat them as a different table, right? I would describe the Redshift tables in Hive, and it would go get them. Hive metastore, excuse me. All right. So they say it works amazing. And we use Athena a lot. And we don't use a lot of Presto, but we use Athena a lot. And I will tell you this much. We generate a lot of files. We get these files in, and we generate hundreds of thousands of files a day. And we had this query that was running against that data. And after about 1.5 years of accumulating that data, Presto gave up the ghost. And I couldn't get it to run in a large cluster either. It just said, I'm not going to open this number of files. I can't do it. And it was the weirdest error. So Presto has some limits, right? It puts it all in memory, tries to do it, but it's pretty amazing. I really like Presto. One of the reasons it is extensible, right, is it has these ideals of connectors, right? So it has this execution engine, which is its heart, and then and then you just add these connectors, right? A connector to S3, a connector to HDFS, a connector to HBase, a connector to Microsoft SQL, a connector to Redshift. And if you go to the documentation and you look at the number of connectors they have, it's got to be 30 and growing. So it's a pretty exciting open source product right now. All right, Spark. One of the nice things about Spark SQL is Spark as a product, right, has many pieces to it, all right? Data frames, it's got RDDs, it has data sets, it has Spark streaming, it has Spark structured streaming, right? It has a graph database interface, and it has Spark SQL, right? So we're just going to talk about Spark SQL, but basically what it allows you to do, right, is interact with your data via SQL when you want to. In this example, right, I'm executing some form of SQL against the database, right, and it uses, again, the Hive metastore, right, figures out the structure, generates the DAG, and executes it, only against its own engine. And then I turn around and I execute a Lambda in a map function against that same data, right? So it's an intermixing of SQL and code. This is one of the reasons data scientists love this tool, right? I can do things in SQL I know how to do, and now I can do some code stuff that is really complicated math that I can't do in SQL. So, oh yeah, and Spark SQL can be run from Java, Scala, Python, and R, right? And it's very closely related to data frames. So we might talk a little bit about data frames. That results object is of a data frame format. It's also uniform, right? Whether I store it in JSON or JDBC or CSV or ORC or Parquet or Avro or however I store it, pulling it out of HBase, I pull it out of DynamoDB, Redshift, it's all executed and managed in the same way, or the exact same interface, right? So today I said I'm going to turn this code into I'm going to turn this result set into JSON and play with it from there, even though I prefer Parquet. It's pretty simple. Wait a minute. So we understand this? Okay. Again, one of the most useful things I found in Spark SQL are the UDFs, right? The user-defined functions. I find them really powerful. They do some really nice things for you. And the interface is really nice because it's this data frame interface. And it's very, very effective. Also, and you'll see this in most tools, but I want to repeat this. JDBC, ODBC connection means that I can use my favorite BI tool. Right? Means that I can use this query language, right, as needed. And I think you'll appreciate the tooling. All right. So let me give you some example code, and we're going to jump into it. But I just want to show you this real quick. This is the product table. No, this is the store table. This is basically what you do to create an entry in the metastore, right? It's the SQL create statement, right? And what I've done at the end, as I said, it's JSON at the very bottom, and it's stored in S3 at QA sonic link data /store. Right? Pretty straightforward. And that's how you create an entry in your Hive metastore. Right? Same thing for product. Right? Data lake product, again, QA sonic link data /product. Okay. All right, so I ran those create statements. I got really loud in here, didn't it? Already, and here it is, product, right? There's product, there's store, pretty straightforward. And my Presto cluster is down. Oh, I'm sorry. Let me introduce this. This is Qubel. Have you used Qubel? If you use big data on a cloud, this is one of my favorite tools. All right, and we'll be exploring it just for example purposes. It manages my Hive metastore for me. It's called the data catalog product. Right, pretty straightforward. If I want to compose a query, right, I can do select. I'm sorry? Make it bigger? Yeah. How's that? All right. So, and I want the POPs version, and I want the POPs amenity, and I want the name, right? And then I'll do from, and then you just pull it over there. Oh, sorry, man. There we go. All right, pretty straightforward. Now what you'll see is, all right, a little slow query there. So the logs will start, we'll see it execute, the job will start up, all right? Give you a little warning there, starting it up. Gotta love Hive. All right. And that's all running on this cluster over here, the Hive cluster. And it's running Yarn. All right, and this is the Yarn interface. As to what's going on, right? Here's the scheduler. Job running here in the scheduler, and you can explore the logs around that. Let's see, where'd it go? All right, is it finished? Nope, still waiting for it. All right. And we'll wait for the results. There you go. Very straightforward, right? Very simple. One thing I wanted to show you real quick, right, is if we take a look at this, this is the execution of a simple query, right? Now these are very small clusters. It could actually run much faster if I had a bigger cluster. We're talking 2 nodes, right? I didn't want Sonic to call me up and go, why is there a 100-node cluster running today? I don't know. So it ran slow, but this query right here, basically I did a join. Ticket header's a large table, store's not that large, right, dimension. And then I did an aggregate, right, by DMA. And this is the DMA and how much was made in there, right? It ran for 7 minutes, right? If you look at the Hive query, you'll see a 24-minute run, okay? So that indicates kind of what we're talking about, right? Let's explore Spark. All right, so with Spark, I like to interface with Spark through Zeppelin, all right? And this is Zeppelin running in Kubel. Now, Zeppelin is free, open source tool, free for you to use. You can set up your own Zeppelin server. If you run EMR, and you can tell it, say, start Zeppelin. And so this tool is available free, right? It's wonderful for Spark. If you're getting into Python, Jupyter is your guy, right? And that's downloaded with Anaconda. All right, pretty straightforward, right? I queried the data lake product right there, right? The %SQL says I'm executing SQL, and then I execute it against the data lake.product, which means I'm using the Hive data catalog, right, to manage my structure. Pretty straightforward, nothing exciting there. Here, I'm actually not running SQL. I'm actually creating a data frame, right? So val equals product is Scala. I read the JSON off of S3, right? And that gives me that product table. And then I call create or replace temp view, which creates another table that I can execute SQL against, called data frame product, right? So here, I am sorting by catalog, summing up the base PLU against data frame product, right? So at this point, I actually have something that has no real analytical value, but shows you kind of what you're capable of doing. That's my result set. But if you want to see the result set in tables, in that format, right? I can remove category from keys, right? And then it's only one thing, right? But I can set it back, right? Drag categories down to here, into the keys, and now I'm back to the keys, right? So it's very configurable, right? And this you get on a Zeppelin, you run your SQL. I think that's pretty cool. And they have multiple different things. I'm not showing this yet, but you can also put in variables you can set in this little notebook. And then so if I wanted to say a date, a start date, and an end date, and I can set that as a variable, 2 variables, right? Okay. Here, I'm showing that I can execute SQL within code, right? So I queried the base PLU, right? And I got a data set that had just that value in it. I'm just trying to show you what you can do. And finally, I ran that same query that took 7 minutes in Presto. I ran it in Spark, and it took about 21 minutes. I actually tuned the cluster today, so I think I can get that down to like 3 or 4 minutes. All right, and there it is, right? So here we see that Dallas-Fort Worth sells the most product. Over here we see Houston doing real well, and Oklahoma City. So the point there is if you have a large data set that just doesn't make sense financially to put into an OLTP system, this is the way you can go. And the tooling is actually pretty nice, right? I mean, this is actually a really powerful option for you, right? As people who are providing SQL action to your companies. Right? So questions?
You said that this is not designed to be an OLTP system, but I have heard that there's a growing slice of products designed to try to help with that, to help specifically with near real-time views, dashboards, that sort of thing with Hive. I think Storm was one of the products that was mentioned. Have you had any experience with those, and do they bridge the gap, or do they still leave you wanting?
Excuse me. Yeah. Storm, well, I'll tell you what we've discovered with Storm. Storm was a good way to turn 500 rows into 540. Right? It's just, basically what Storm says is, I'm not sure you got that, let me send that to you again. Right? So you would kind of have to clean up on the other side. And it's nice because you don't ever lose any data. I'm not impressed with Storm at this point. I think probably the most interesting thing, if you're trying to do real-time data provision, you might want to look at a data pipeline, right? Depending on what your expertise is. I hear stream sets is really nice. We use Spark structured streaming simply because we know Spark and Scala. And then I know Loves uses the Apache NiFi, and Devin uses stream sets. So that's really a way of kind of real-time getting data somewhere. Within EMR, there's a new product called Apache Flink, which is, I hear, sort of a, so what Spark does is they macro batch near real time, right? So small batches very quickly. Flink, my understanding, is real-time delivery, right? They're not micro batching, they're real-time putting it in. So if you are going to do some near real-time stuff, you might want to look at some add-on products like Kafka. Yeah, so that's one of my favorite big data open source tools. So, and Kafka is kind of a queuing mechanism. It's really powerful for putting large data sets into a place, right? So you've got something over here sending data, right? You put it into Kafka and then you pull it out as you need. And it hangs out there for 7 days, right? So if you've got something that batches it, that's cool. If you got something that's real time in it, that's cool, right? So it's just a way of sort of having a data store right there. And Presto has a connector for Kafka. So if you want to query your data directly on a Kafka, you can do it with Presto. Any other questions?
So I came from a Microsoft SQL background, and
All right, so it kind of begins with your distributed file system, right? So in a distributed file system, you distribute the storage of the file, right? So I have a file that's 100 gigabytes, right? HDFS or S3 will take that and break it up into pieces and store it multiple times across your cluster, right? So let's say it's stored in 100 different pieces, right? Now you go and you say, query that, right? Sum it up and give me the result. What it does is at that point, the execution engine looks at it and says, okay, it's in 100 pieces. I need 100 tasks to go read that data, right? Process it, right? And then return it in 100 pieces of data, right? So generally it does by the data the way you store it. And that's one of the things we do when we store stuff, is you'll see this coalesce thing that we do. And we say, so when I was reading ticket header in and I wanted to store it in a smaller format, I had 4,000, 5,000 tasks, which meant that it read across multiple files, and those files were broken into smaller pieces. So there was 5,000 different processes reading data, right? And if you use HDFS on-prem without a SAN, it will actually it'll store the data in each chunk 3 different times across your cluster, and then will attempt to put your execution on the same machine as where your data is stored, right? So you can get a real performance boost from that. So then MapReduce, what it does is it says, all right, let's build that directed acyclic graph. So here's some work I need to do. Let's turn that into 100 tasks. Let's go tell Yarn to start it. And then you execute your code through Yarn. And what happens with MapReduce is MapReduce goes, I read the data, I process it, and I store the data, right? And the next step, reads the result, processes it, and stores it. And this is fantastic when you have a huge data set and you don't have a lot of memory, right? Because it will chunk through it and it will do it, right? All you got to have is a lot of hard drive space, which is pretty cheap, right? But again, turns your 12-hour query into a 3-hour query, turns your 5-second query into 2.5 minutes, because there's so much disk I/O. They came along and they created Apache Tez for Hive, right? Spark SQL does the same thing, right? Presto does a similar thing. Says, I think most of this could be stored in memory. Memory's getting cheaper. Let's try to store this in memory. So that's what they do. Apache Tez and Spark SQL says, let me try to fit that in memory. That's not fitting. Let's start putting it in the hard drive, right? So we see a lot of performance improvements that way, but it's still directed acyclic drive, right? Graph, data in, process it, data out, right? Now what happens is, what gets ugly is, right, a join between 2 tables, right? You can't really, so there's 100 pieces of that table and 50 pieces of that table. Well, you have to 50 times 100, right? You gotta look and see if it matches. So it can be pretty, pretty ugly. But if you have enough machines, right, whether it's, if you have 5,000 possible tasks that can run at one time, and it's going to take 10,000 tasks, and tasks take a minute, you've done it in 2 minutes. You've done 10,000 tasks in 2 minutes. Now, if you have 2 machines, Friday it'll be ready. But it keeps up and it runs, right? It doesn't stop. Does that make sense? How it works? Okay. Questions? Does anyone have this kind of data? Anyone thinking, boy, I could really save my company a big chunk of money. I could start building some of those indexes I've been wanting to build if I could just get this crap data out of here. No? Everyone has perfect data. You're perfectly happy with it. It's just your baby. I can't let go of it. Mm-hmm. Right? Where do you want to start? The easiest place is a cloud. Unless you're comfortable, throwing up a Docker or a virtual box on your machine, right? That's cool. You can get Hadoop in a VirtualBox and play. But the cloud is a little easier, right? Like with me and Cubel, right? I didn't have to set up a relational database, and I didn't have to configure it so that Spark and Presto and Hive could read from it, right? It was all done for me. So it was much easier to do this presentation. Go ahead.
What drives the data structure?
I'm sorry, what?
What drives your data structure? So in other words, you're breaking this data up into all these multiple files.
Right.
So my question is how does that process work? Or how do I get the data to a file? Because like I have traditional business SQL analysis services. We don't have a lot of that data, but we still have, we use like oil and gas pipes. So there's
Okay.
millions of pieces of information that have certain metadata about it. And this, a smaller version of this might work a little bit better. But my question is how do you get your data to a structure that it can read?
Okay.
You have to use like integration services and say, hey, I want you to break this out to a JSON file.
Right.
And then bring it back in. Is that how that works? Or is it daily split? Just kind of
Are you trying to learn, or are you trying to like deliver something to the business?
trying to do both.
Okay. From a learning perspective, I would take a small data set and move it down to your laptop, right? And if you want to learn Spark, right, download Spark and start playing. And there's no need for Yarn or anything. Spark will run fine, right? If you're doing a big data set, you've got to have an Hadoop cluster or a Mesos cluster. If you're doing something real and big, right? The easiest way to do that, and I think the cheapest way, is do it on the cloud, right? And the thing I love about Cubel is I could shut this laptop and walk away, and both these clusters will shut down after an hour. And I'm not paying for it anymore, right? That's pretty nice. So that is one of the advantages, I think, to the cloud and this solution, is I only bring up hardware when I need it. I'm not running hardware when I don't need it. Right now, Loves, and I had this conversation with them, Loves runs a 20-node cluster. And they, huh?
Yeah, I do.
Oh, you work at Loves?
Yes, sir.
Okay. And it has to stay up all day, 24/7. And they have to pay for it to stay up 24/7 because they store their data in HDFS. And HDFS has advantages over S3, right? But they have to pay for that EC2, right? We don't pay for that. We got away from that, and we said all this coming in, we're going to put it in Kinesis, and we're not managing clusters. So we're just starting them up, using them, and shutting them down. And there's advantages back and forth, right?
One of the things that was talked about internally is, because we've looked at other, like I've seen demo here at Snowflake and other S3-based solutions. One of the things they talked about was if we're concerned about extra cost and hidden cost of running in the cloud. So can you say why you, it seems like, in other words, it seems like my organization has a little bit of glass supports on-prem.
Yeah.
And how do you, if you were to argue the other side, what do you say to people that think that there's, that it's not cheaper to go to the cloud?
You're talking about on-prem? Yeah. A lot of it depends, okay, so one of the things we did is we get data flowing into our system through multiple sources, real time, lots of different data sources, and we store it every 10 minutes, right? So we're not creating big data systems, we're creating thousands and thousands of files, right? And AWS charges you every time you list and look at a file, every time you read a header of a file. So Athena, we go, Athena, hey, go do this on this, right? And then we get this bill at the end of the month going, why is there like 50 million file opening costs? And that actually adds up pretty quickly. So a lot of it comes back to how, like he said, data storage is, if we're doing these big data scans, we probably want to start putting that data into a bigger file. Of course, getting your management to put that on your priority list is, well, it's difficult for us. It may be easy for you. But. So file size is going to be very important, right? A really large file means that you're scanning a lot of data that's not necessary, right? How you partition the data, right? We partition our data generally by business state, and that allows us to only open sets of files within the business state range, right? Go ahead.
So to play on this question a little bit more, if you're trying to sell on-prem to on-prem versus in the cloud, one of the things I've done is I compare 100% uptime in the cloud price to the on-prem price, so that you kind of know where your maximum ROI.
Yeah.
So they can run for like server runtime, server uptime, but file access becomes that biggest one. You don't know to guess.
Yeah.
So I would think, is there an easy way to guess how much your values would be then, or is there an easy way to find average?
No.
Or would you say it's proportionate to server?
It's like next to impossible to figure out what AWS is doing that month when it comes to file storage costs.
So yeah, then all you can really do is say what your server time or your server's going to cost and let them know.
But they offer a calculator, and you can use it. When we were making these cost estimates, we were planning 20 node clusters similar, and when we started looking at the long-term cost of that versus buying some on-prem hardware, there wasn't any comparison. But of course, AWS offers lots of different options on how you pay for one, right? If you're just paying for it to rent one by the hour, it gets expensive. But if you're buying one full time, it gets a lot cheaper.
You also you're paying for it to like the yearly value, so you buy it for 3 years set price on a lower percentage
Right.
of its cost. And
Yeah.
you also take into consideration not only how much you can use the server, but at what level of VR you now have
Right.
for what it is the company extra
Yeah.
perks you're getting going on versus a single server or however you do it on your own side.
Right. I honestly, if I were doing Loves, and you really want to do HDFS, I'd shut down 15 of those machines and just leave 5 running all the time. I don't know if you need all 20, and maybe you do need all 20 for NiFi, I don't know. But you have to have those running for HDFS. And you can't shut them down and start them back up, right? Because it stores it 3 times, and if you shut down 3 of the machines that has pieces of that file on it, that file's not available. Right? Now you shut down one machine, it'll move it for you. It'll start moving it and replicating, right? You shut down 3 or 4 machines at one time, you don't know. Yeah, you don't know what your data you lost.
So then would you advise something like S3 if you want to go to more after call?
If they were going to do more of it, like if they're going to start doing really large, right, queries, right, where you want to start up a good sized cluster, I like starting it up and shutting it down. Just makes sense. Yeah. I always felt like, and I don't think this is true anymore, I felt like we'd get out in the cloud, we'd get a really good idea as to what we're doing, and then we come back and look at what that looks like on-prem, and we could save a lot of money. I've always felt like that, but our management is not interested. So,
Well, there's more to the cost of the server and the cloud versus on-premise.
Yeah.
So some of the things you're selling there is reducing not only manpower, HR overhead,
Right.
management of building space,
Mhm.
even building costs, how you handle your servers,
Right.
the need for security in your on-premise site. If someone's going to come in and steal one of your servers out of your closet, $20,000 for the
yeah.
server.
Yeah, but I don't think AWS is giving anything away. They're doing all right, I think. So, yeah. So there's definitely a profit margin. Maybe we couldn't achieve it because of their scale. You know, it's hard to say.
But do you feel like that doing your proof of concept and your initial run in the cloud, that there is a point at which you can come back to on-prem and save money once you have a stable idea,
Yeah.
a stable solution?
I know that when we started out with a Hortonworks cluster, 20 nodes, and we said, all right, let's set it up this way, right? And sure enough, Kafka would choke when a Spark machine ran out, or there was no way to run HBase on our cluster, right? So we began talking to people, and they're like, oh, you want Kafka on its own machines, and you want really high-speed drives, and you want those 3 machines dedicated to Kafka with. And then you can't put HBase on another, you can't share HBase machines. in that system because it's not using Yarn. So we discovered a lot after about a year and a half as to what our cluster should look like. So I think the flexibility of the cloud is nice. Okay. All right. Thanks, guys. Yeah.